In this video, you will learn how to find the magnitude of a vector, how to multiply a vector by a scalar, and how to add vectors. Now to begin, we first must define what is a vector. Well, a vector, by definition, is any quantity that has both magnitude and direction. Magnitude meaning an amount or a quantity. So for example, we would have things like force, velocity, or acceleration would be examples of vectors. So force, for example, let's say we pushed an object this direction. Let's say we pushed with a force of 20 newtons and went in this direction. That would be a vector because it has direction and it has a magnitude or amount given to it. Same idea with velocity and acceleration. Those would be vectors as well because they have a direction as well as an amount. So like velocity maybe like 20 miles per hour south. Okay, that would be a magnitude and a direction. So to illustrate vectors, let's say we have a car that travels from point A to point B. So here we can graph this on a coordinate plane. And point A is here at the point 2, 1. And point B is up here at 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. It'd be 6, 8. So this vector goes from 2, 1 to 6, 8. All right, in English, we would call this vector AB because it goes from point A to point B. In math notation, we can write that as AB and then a vector symbol above it. Notice this vector symbol, maybe kind of hard to read with the typed up notes, but what it is it is a line, but without the bottom part. So it's like this, and then just the top part of a line. So a line would have, this other bottom part, but a vector doesn't have that bottom part. So it's going to look like this. Now, a vector can be defined as a change in x and then a change in y. So it's a point or a order pair where the x value or the first number is the change in x and the second number is the change in y. So in this example, the change in x would be how far to the right or left is it going? Well, it's going over to the right 4, so that's a positive direction for x, so the change in x is a positive 4. And then change in y is how high up is it going? Well, it's going up in the positive direction, and if you count these spaces, we will count that to be 7. So it goes up 7 units. So vector AB can be defined as 4, 7. All right, so this ordered pair is not just an x and a y, but it's the change in x and the change in y to get this ordered pair. Here's a second illustration. So here we are told that a vector starts at point A, which is -5, 6, and then goes to point B, which is -1, 2. And we're trying to name or label this vector. All right, so if we find the points A and B, A would be up here, -5, 6, and B would be over here at -1, 2. All right, so if we wanted to identify vector AB, again, is change in x and then change in y. That is our ordered pair. All right, so to determine this, we could count, as we did in the last one, just see how far to the right is it going and how far down is it going. But we don't want to have to do that every time. We want to be able to look at the points to determine what is our vector. So the change in x will be found by subtracting the two x values. So when you do this, the order does make a difference. It is important that you're subtracting the end point by the beginning point. So this first point here where you start would be like your point 1, that'd be x1, and this would be y1. And then your second point would be x2, and then y2. So that's your first x and y value and your second x and y value. And when you find the change in x, you're going to subtract the two x values. You do x2 minus x1, the ending point x value subtracted by the beginning point x value. So you do -1 minus -5, and minus negative 5 becomes a plus 5, which would be a positive 4. And then you do the same thing for the y values. The change in y is y2 minus y1, or 2 minus 6. So 2 minus 6 would be negative 4. So the vector AB would be 4, negative 4. So the x and y value, the first number and second value, are your change in x and your change in y. And we can verify this by counting. If you see how far to the right is it going, it goes over 4. So that would be your change in x. And then the change in y is how far down is it going. So down is a negative direction for y. Count 1, 2, 3, 4. It does go down 4 units. So the change in y would be negative 4. So again, this vector, vector AB, would be 4, negative 4. Now with vectors, we said that vectors have magnitude and it has direction. So next we want to be able to calculate the magnitude of any given vector. So to do that, it's going to be based off your Pythagorean theorem. All right, so in this example here, we have this vector AB, and the change in x is 4, the change in y is 7. All right, now magnitude, again, is going to be the distance between the 2 points, how far is the vector going. All right, and it can be thought of as the length of the arrow. So the magnitude of vector AB is figuring out how far or how long is this arrow from point A to point B. All right, and in math notation, instead of writing out the phrase magnitude of vector AB, we could just put absolute value symbol around that vector AB. So here, notice we have this notation with the vertical line to see your absolute value symbol. That means absolute value of vector AB, or I guess the magnitude of that vector. So that is the length from A to B. So here, if AB is 4, 7, that's your change in x and change in y, you're told to find the magnitude of AB. Again, we can use our Pythagorean theorem, because what we have is a right triangle. Right here is your right angle, and the hypotenuse is this vector over here. It's across from the right angle. So your Pythagorean theorem is c squared equals a squared plus b squared. Then a and b would be the 4 and the 7. So you do 4 squared plus 7 squared, that's equal to c squared. Then you solve it, you get 16 plus 49, which that gives you 65. So c squared is 65, which makes c the square root of 65, which would be approximately 8.1. So the magnitude of vector AB, we would say is 8.1. That is the distance from point A to point B. So again, notice where those numbers came from, the 4 and the 7. That was your change in x and change in y. All right, and we can get those numbers directly from right here, this order pair. So the vector AB is 4, 7. So the 4 and the 7 for your Pythagorean theorem comes from that point, or that order pair. So we could just plug that in for A and B to figure out what is the magnitude. Okay, let's try another example. So here is example 2, and here the vector AB is 4, negative 4. That is the vector. And we're trying to find the magnitude of vector AB. So see if you can do this one on your own. All right, so once you've tried it, you can now check back with the video, see how you did. And for this one, again, we're going to use Pythagorean theorem, which is c squared equals a squared plus b squared. So in this case, a and b would be the 4 and negative 4. That is your change in x and change in y. That is the lengths of the legs of this right triangle that was created. So just plug that in for a and b. We have 4 squared plus negative 4 squared. So 4 squared is 16. Negative 4 squared is also 16. So 16 plus 16 is 32. So c squared is 32, which means c would be the square root of 32, which is approximately 5.7. So the magnitude of vector AB, the length from point A to point B, is approximately 5.7. All right, so we've learned how to identify a vector, how to assign it to an ordered pair. We've learned how to calculate the magnitude. Next, we are going to deal with what is called scalar multiplication. The word scalar is basically just a number, a constant, that we're multiplying the vector by. All right, so that's what we're doing. So here we have a vector. We have vector mn. And if you were told to find 2 times vector mn, so 2 in the front means times, so 2 times this vector, what it means is that we want the magnitude to be twice or 2 times the magnitude of vector mn. So it's going in the same direction. It doesn't have to be starting at the same point necessarily, but it's going in the same direction but twice as long. So if that's vector mn right here, 2mn would be right here. So it's a vector that is twice as long, going in the same direction. Now if you had negative 1/2 times mn, the 1/2 means that the magnitude is half the magnitude of vector mn, which means it's going to be half the length. And the negative indicates that it's going in the opposite direction. All right, so that would look something like this. So notice we're going the opposite direction, and then we're also, it's 1/2 of the length. So it's 1/2, and there should be a negative here. It's 1/2, and it's going in the opposite direction. All right, so that's what scalar multiplication means. It just means it's going to be multiplied by that number. Which, by the way, if you were given vector mn, let's say we were told that vector was, and actually let's see here, mn was what, up, no, to the right 1, 2, 3, 4, 5, up 2. So the vector was 5, 2. So when it says 2mn, basically you're just going to be multiplying both numbers by 2. So you have 10 and 4. So we see here, that's what happens with 2mn. It goes over 10 and up 4. And that gives you this endpoint now. And same thing with the negative 1/2 mn. So negative 1/2 of that vector. So you take 5 and 2 and multiply by negative 1/2. So 1/2 of 5 is 5/2, or 2.5, but it's negative, so negative 2.5. So negative 5/2, 2.5. And then negative 1/2 times 2 would be negative 1. All right, so that's what we see here. It goes over to the left, 2.5, 1, 2.5, and then it goes down 1 right here. And that's how we find the endpoint. All right, so that's how you would multiply with a scalar. Next, we have what are called parallel vectors, and then we have perpendicular vectors. And it's pretty much what it sounds like. So parallel vectors would be going in the same direction. Okay, so it has the arrows pointing in the same direction, but it could also be in the complete opposite direction. We'll look at that in a second. And the important thing is the slopes will be equal. So some examples of parallel vectors would be right here. Notice we have, the top 3 are all going in the same direction, same slope, but the bottom one is going in the opposite direction, but it's still going to be parallel. So you can almost imagine this as being a line extended in both directions. Okay, it's going to be parallel to the ones up here. All right, and even this one, so look at the 2 middle ones here. So these two, even though they are technically like collinear, it still is considered parallel because they are going in the same direction, they have the same slope, so that's okay. All right, so those would be parallel as well for vectors. Now we also have perpendicular vectors, which is really what it sounds like. It's going to be 2 vectors that create 90-degree angles. All right, so they're going to be vectors that have arrows pointing in perpendicular directions. And for this, the slopes will be negative reciprocals of each other. So for example, we have these 2 vectors. So this first one right here, the one going from left to right, if we can verify that the slopes are negative reciprocals by counting. So it's rise over run. It goes up 1, 2, let's see, 1, 2, 3, 4, up 4 over 10. So the slope of that line is 4 over 10, which would be 2 over 5. Now the other vector right here, again, rise over run. So we're going to go up, and it actually goes up 10. Then it goes to the left 1, 2, 3, 4. It's supposed to be going right here at this point. That was the intent. So it's going up 10, and then to the left 4, which would be a negative 4 for the x direction. So again, that can reduce. You're going to get negative 5 over 2. So notice the slopes are negative reciprocals. The one was positive, the other negative. The one was 2 over 5, the other is 5 over 2. So we verified that indeed perpendicular vectors will have slopes that are negative reciprocals of each other. Next, we also have what's called equal vectors, and by definition, they will have the same magnitude and same direction. So an example of this would be right here. We have two different vectors that have the same direction and they have the same magnitude, meaning they're the same length. All right, so these would be equal vectors. So even though they have a different starting and ending point, okay, the vectors would still be equal. Same magnitude, same direction. So here we have an example. We are told that we have point C to be 1, 5, point D is 3, 9. We're given vector Mn is 2, 4, vector Fg is 8, negative 4, and vector AB is 8, 16. And for this example, it's got multiple parts to it, and what we're trying to do is kind of put everything together. So we're getting some review of the different concepts we've talked about. And here, we're trying to find vector CD, and then we are also finding the slope of each vector. And then from the slopes, we are determining which vector is equal, parallel, and perpendicular to vector CD. All right, so if you need to, you could try to draw this out, but we're going to start with part A with points C and D. So remember, to find a vector, vector is defined as the change in x and change in y. And by the way, the notation for that, we could write out the phrase change in x, but you will start seeing as you progress in upper level math, the symbol for change in something would be an upper, like a triangle. So it's a capital delta, it's a Greek letter. So here would be change in, and then change in x. And then we have also the change in y. All right, so the change in x, we can find that by looking at the 2 points. We have x1, y1, and x2 and y2. So the change in x would be x2 minus x1. So that'd be 3 minus 1, which would give you 2. And the change in y would be y2 minus y1. So 9 minus 5, which gives you 4. So we have the vector CD would equal 2, 4. So we have found part A of this problem. Now to find part B, we want to determine the slope of each vector. All right, so this one, we've learned to find slope. We have a slope formula, which is what, y2 minus y1 over x2 minus x1. So you've learned that in the past, right? That's your slope formula. Well, all these points here for the vectors, that's really what these points are. So like we just found vector CD to be 2, 4. That was your change in x and change in y, right? This was x2 minus x1. This was y2 minus y1. We just found that. Okay, that's for all these points. So to find the slope of a vector, basically, we just take y, this y component, this change in y, the 4, that's going to be the top, and then divide by the x component, the change in x, which was 2. So we have 4 divided by 2, which is 2. So the slope of CD would be 2. All right, and then the slope of MN, right here, remember the 2 and the 4 are x2 minus x1, y2 minus y1. We already have the numerator and denominator. So the numerator is going to be the 4. That's your change in y, y2 minus y1. So the slope of mn, we do 4, and then divide by 2, the x value, which is 2. So the slope of CD is 2. So the slope there is 2. The slope of mn is also 2. Okay, the slope of fg of this vector, we take negative 4, divide by 8. Your change in y over change in x, y2 minus y1 over x2 minus x1. That's negative 1 over 2. Then for vector AB, we do 16 divided by 8 to find the slope, which would be 2 over 1, or 2. And we see that all typed up right here. Okay, we have the slope of 2, 4 is 4 over 2. Slope of 8, negative 4 is negative 4 over 8. Slope of 8, 16 would be 16 over 8. All right, so we found all the slopes. And then part C is we're determining which vectors are equal, parallel, and perpendicular to vector CD. Well, CD was 2, 4, we said. To be equal, it's going to be the same. So we notice that vector MN is also 2, 4. So MN and CD are both equal. So those are equal vectors. All right, it's got the same slope. It's got the same magnitude. It's identical, same exact numbers. So that's a quicker way to determine is just see, does it have the exact same numbers? Are they equal? All right, and then for parallel, we're looking at which slopes are the same. So the slope of CD was 2. We already found that. So notice that MN would also have the same slope. So MN has the exact same point, so it's going to have the same numbers plugged in. So MN has the same slope. And then notice down here, 8, 16, that was vector AB. That also has a slope of 2. So vector CD, MN, and AB all are parallel. Now the last part is determining which vector is perpendicular to CD. So we said CD, the slope of CD, so the slope of CD was, we already said, 2. All right, so to be perpendicular, okay, it's going to be the negative reciprocal slope. So instead of 2 or 2 over 1, it's now going to be a negative, and then reciprocal would be 1 over 2. And notice that would be right here. That's the slope of 8, negative 4. 8, negative 4 was FG, that vector. So FG, we would say, is perpendicular to vector CD. All right, so this kind of recaps everything we've done up to this point with vectors. So we've had to determine the slope, we had to find vector CD, we determined parallel versus perpendicular versus equal. We did not, in this example, discuss magnitude, but we have already seen some examples with that previously. And one last thing to discuss is what we call vector addition. So vector addition would be the adding or addition of two vectors. So the rule for adding vectors is, let's say we had vector AB. So let's say the first vector is this ordered pair of AB, and the second vector is this ordered pair of CD. So to add the vectors together, you just add the x values, A plus C, then you add the y values, B and D. So you add the x parts and then the y parts, and that's your new vector. So to illustrate this, let's use an actual scenario. Let's say that we are traveling on a ship, and the ship travels from point M to point N, and then from N to point P. So the ship could have just traveled from M to P directly instead of stopping at point N. So the way we can write this is we can write this as Mn, so that's the traveling from point M to point N, so that's vector Mn, plus from N to P, that's vector Np. It's got magnitude and direction. And together, that would equal the vector Mp, so directly from M to P. All right, so that would be the addition of those two vectors. So let's say we had Mn was the order pair 5, 2, Np was the order pair 3, 5, and we were asked to find what is vector Mp, what is the addition of those two. So what we would do is to add them together, we'd add 5 and 3 for the first part of the order pair. That gives you 8. then we add the 2 and the 5 right there, and that gives you 7. So vector MP would be the ordered pair 8, 7. And graphically speaking, it would look something like this. So we go from M to N, we went from N to P, so the addition of those two vectors would be this resulting vector right here from M to P. So it'd be this vector here in red. So the vector MP would be 8, 7. And we can verify that because 8, 7, that tells you the change in X and the change in Y. So if you count how far to the right is it going, it goes over 8, and then the 7 is the change in Y. So it indicates how high up it's going, and it's going up 7 to take you to this point. So it goes to the right 8, up 7, and that takes you to point P. So we verified that we do indeed have the correct answer when we added those two vectors, and the answer is 8, 7. And that concludes our lesson for today. We will see you next time.